including van der Waals force, temperature, and other things. Then that's why it is not too specified. The adsorbate molecules attraction is not affixed to a particular site on the surface, but it is free to move about over the surface. तो ऐसा क्या है कि अब ये adsorbent है, it is not going to sit adsorb on the surface. It may be going to adsorb here or something. In addition, this adsorbed material may condense and form several superimposed layer, multi-layer adsorption on the surface of the adsorbent. So this is possibility there, that is good. By this, you are actually able to get a good QE value. And always remember, in adsorption, there is a two common thing. In lab, what you did, two students developed two adsorbent. One student got 99% removal and adsorption capacity is 50 microgram per gram. In his is as per his laboratory condition. Second student got 95% removal and 200 mg per gram. Can anybody explain the significance of both data? And commercially, which one is going to be good? Commercially, which is going to be good? Tell me. बताइए commercially which is going to be good? Case 1 or case 2? B. Amit Kumar Arya, good. Why? Because using 1 gram of activated carbon, you can remove 200 milligram of pollutant. On using 1 gram, you can remove only 50 gram. So, one solution is there, and that solution have 200 milligram pollutant, and even though your removal efficiency is 99 or 100, you need 4 gram adsorbent. Here, it's a 95%. So what will happen? Only 1 gram adsorbent is sufficient, or maybe 1 point something. So you will find that there is a 4 times more adsorbent is required. Commercially, it have a more viable. Generally, quite reversible. What is meaning of this thing? With a decrease in concentration, the material is dissolved to the some extent that it was originally adsorbed. Important line. Generally, with reversible, with a decrease in concentration, what happened? Initially, concentration is 200. Now you are going to put adsorbent. Their concentration 200 to 190, 180, 160, 150. Then again, it may possible that now some extent what will happen, it is the reversible, and it may possible that some adsorbate is going to dissolve from this surface, because it is a physical process, there is no chemical bonding, and that's why it may be possible. Now, chemisorption. So what is chemisorption? In this type of adsorption, the adsorbed material forms a layer over the surface, which is only 1 molecule thick, that is monolayer. And the molecules are not considered free to move from one surface side to another, because they are chemically bind. When the surface is covered with a monomolecular layer, the capacity of adsorbent is essentially exhausted. So we can say that QE is very less. Because why QE is less? Here only monolayer is there. When monolayer is there, so what natural QE is going to be less. Completely stronger force of binding, but here force of binding is going to be high because it's monolayer. Each side is available for each adsorbent. Process seldom reversible. The adsorbed material must generally be heated to higher temperature to remove the adsorbent material. Okay? If you want to remove this thing. Generally, some combination of physical and chemical adsorption is responsible for activated adsorption in water and wastewater. This is very important. So what happened? What happened? Sometimes we chemically modify with the help of simple H2SO4. What will happen? If you are going to soak your activated carbon in H2SO4, what is going to happen? What is going to happen? Tell me. Tell me. आप एक्टिवेटेड कार्बन को H2SO4 में सोक करेंगे, then what is going to happen on the surface of this thing or chemically or physically? Oxidative functionality is going to increase or not? But natural. Yes. Because H2SO4 have a this thing sulfur, and because of that, chemical substance is going to be occur. Exchange adsorption. कहाँ पे होता है exchange adsorption? Ion exchange process. I think when my previous semester, I think all MTech students they are aware about that thing. That time I discussed about those things. In ion exchange, there is a cation reagents and there is anion reagents. So what happened in those reagents? Ions are exchanged. So by exchanging the ions, we are able to remove the adsorbate from the bulk solution. So here, ion exchange is included. Ions of substances concentrate at the surface as a result of electrostatic attraction to the side of opposite charge on the surface, and that's why it have a two regime, cations and anions. It is going to be more clear. Let me show one slide. Because some student from other than environment background, that's why I want to show this thing. You just see. These are the resin. Cation exchange resin. So what will happen here? H ion is going to replace with sodium ion, and what will happen? It is going to be more clear in this equation. So if water have a calcium and magnesium, so what will happen when it is going to pass with the cation exchange resin? The calcium from the water is going to adsorb on that resin, and that hydrogen ion is going to release in that bulk solution. Same is applicable for magnesium. So what will happen here? This hydrogen ion now is available in bulk solution. So in after cation exchange column, what we are going to pass the water to anion exchange column. Here what will happen? It is exchanged with the chloride present in the water. Again, now that chloride is going to adsorb on the surface and this H ion is going to rise. So here the thing is that adsorption is going to occur only when there is something is there to exchange. If that water did not have any ions, so no adsorption will be there. Why? Because they do not have to anything to exchange. Okay? So that is nothing. It is a ion exchange process. So ion exchange, we know that basically the ion with greater charge, such as trivalent ions, are attracted more strongly towards the opposite charge, but natural. The ions which have a more charge, it is going to be exchanged more faster than this thing. The smaller the size of ion, the greater the attraction, but natural. Now, although there are significant difference between these three types of adsorption, but sometimes it is very difficult to assign a given adsorption to a single type. So you are going to get when you are going to read when you are going to read a adsorption based book or manuscript or anything. Most of the time you'll find that researchers they write like that. The possible mechanism behind this adsorption may be physiochemical. So that's why sometime maybe they write that it may be combination of exchange. So that's why, or we can say that most of the time it is because of the exchange, or maybe because of physical, or maybe chemical, or maybe combination of physical plus exchange or chemical plus exchange. And that's why it is very tough to say that a particular adsorption is done only because of the chemical process. So as adsorption is a surface phenomena, the rate and extent of the adsorption are function of the surface area of the solid burst material, because whether you are it is a exchange process. So in exchange process, if sufficient surface is there, then it is going to be more exchange is possible. Even it is a chemical process for doping and other things, its surface is required. Even it is a physical process, again surface is required, and that's why surface play very important role. And whenever you are going to when you are going to work in field of this adsorption, you will find that your professor is going to ask, once you, sir, I have developed one activated carbon from this particular waste material. So first he is going to tell, go for BET analysis. What is BET analysis? Tell me. What is BET analysis? Why is that professor want to this analysis? Suppose you develop one activated carbon for surface area. Good. BET analysis is required for surface area. Suppose you develop one activated carbon, and people say it is mind-blowing activated carbon, and because I develop from the material which is useless material and people are throwing, but we are able to. And after BET analysis, you find that the surface area is only 500. So even though it is a very cheap, but the thing is that the surface area is 500 meters square per gram. It's very less. If surface area is less than 800 or 900, is almost there is no meaning. And if you are able to develop activated carbon having surface area 1500 in your master thesis using any way or any method, you need not to do adsorption study. That is more than sufficient. And that is the area of material science. You got my point? So activated carbon has been externally used for adsorptive purpose because of its tremendous surface area with respect to mass. 1 ग्राम में कितना मैंने दिखाया? 1000 meter square. That is the quality. AC prepared from many sources: wood, coal, lignite, nutshell, bone. A lot of people prepare this thing using from a lot of material. Sometimes people develop activated carbon using leaves, sometimes from some other material. Now, generally made from coal or wood product by heating temperature between 300 to 1000 degrees centigrade in any of the possible gases atmosphere such as CO2, air or water vapor, and immediate quenching in air and water. Okay? This result is structure with remarkably small and uniform. Our ultimate goal is that it should be small. What is the benefit of small? How this small size is going to help? Tell me. Because if activated carbon size is small, it means it's a representation of bigger surface area. Thus, basically, the quantity of substances absorbed by a given sample, the quantity of substances absorbed by a given sample of adsorbent depends upon the nature of material, means surface area, oxygen functionality, and its concentration along with temperature and other. Let us see what other described below. Factors that affect adsorption extent and thereby affects isotherm. What is this isotherm? Can anybody define what is isotherm? Thermal at a different temperature. What is here iso? What is here iso?
Sir, isotherm is same temperature.
Same temperature. What is the significance of this isotherm?
We can find relation between adsorbent and adsorbate, sir. Using this isotherm.
At a constant temperature, when we are able to establish the relation between adsorbate and adsorbent. Simple efficiency of adsorbent at a constant temperature. Yeah, right. So adsorbate and adsorbent characteristics. Next is degree of solubility. In general, the solubility of solute increases, the extent of adsorption decreases. Why? Solubility of solute increases, the extent of adsorption decreases. बताइए. That's why I'm highlighting.
Because if solubility increases, then more molecules won't adsorb on the surface of this,
Pardon?
on the solid.
It's not clear actually.
Sir, if solubility increases, then it won't adsorb on the solid surface.
Yes. Adsorption side may be reduced as concentration increases. Right. Solute-solid interface binding complete with a solute-solvent attraction, but natural. The less soluble the material, the more likely it is to become adsorbent. Next slide. With molecules containing both hydrophilic or hydrophobic groups, the hydrophilic ends of the molecule will tend to become attached to the surface. And that's why it is very tough to find adsorbent or to develop adsorbent which is hydrophobic. Factors which affect solubility include molecular size, high molecular weight, lower the solubility. High molecular weight means we same time we can get the component which is long chain compound or something like that. Then ionization rate of molecule please write down attendance. And tomorrow you people have classes from 6 p.m. Amit, Arya, tomorrow you have class after 6.
No, sir.
So can I take tomorrow as a one extra class?
Yes, sir.
Okay.
सर बीटेक
Yes,
वालों
sir.
का पता नहीं होता होगा कुछ क्लास.
That's why I'm asking from everyone. Anybody have
BTech.
any class after 6
BTech,
p.m.?
no class.
Sir.
No,
Then
sir.
it's okay. Then it's okay. Tomorrow there will be class from 6 p.m. Those who had given their attendance, they can leave the meeting.